On October 11th, 2025, a team of archaeologists diving off the coast of Turkey made a discovery that changes everything we thought we knew about how humans left Africa and populated Europe. They found a lost land bridge now hidden beneath the Aegean Sea that once connected Asia to Europe during the Ice Age. This wasn't just a small pathway. This was a massive corridor, over 100 meters above today's sea level, stretching from western Turkey all the way to Greece. For decades, scientists believed humans migrated into Europe through two main routes, the Balkans in the north or the Levant in the Middle East. But this discovery proves there was a third route, a hidden highway that's been underwater for over 11,000 years. And here's what makes this absolutely mind-blowing. They found 138 ancient stone tools scattered across this sunken landscape, tools made by both Neanderthals and early Homo sapiens. This means two different human species walked across this land bridge, hunting, gathering, and migrating into Europe through a route we never knew existed. This isn't just another archaeological find. This is a complete rewrite of the human migration story. Welcome to the greatest discovery of 2025, the lost land bridge that changes everything. Before we dive into this groundbreaking discovery, let's understand what scientists have believed for the past century about how humans reached Europe. The story begins in Africa, approximately 70,000 years ago. Our species, Homo sapiens, emerged from the African continent and began one of the most important journeys in human history, the Great Migration that would eventually populate every corner of the earth. According to the traditional theory, humans left Africa through the Sinai Peninsula and moved into the Middle East, specifically the Levant region, which includes modern-day Israel, Jordan, Syria, and Lebanon. From there, they had two main options to reach Europe. The first route was through the Balkans. This northern pathway took humans through modern-day Turkey, Bulgaria, Romania, and eventually into Central Europe. Archaeological evidence from sites in Bulgaria and Romania shows human presence dating back 45,000 years, supporting this northern corridor theory. The second route was the southern Mediterranean pathway. Some researchers believed humans may have crossed from North Africa into southern Europe, possibly using primitive boats or crossing during periods of lower sea levels at the Strait of Gibraltar. For generations, these two routes dominated our understanding of human migration. Every archaeological discovery, every genetic study, every Paleolithic tool find was interpreted through this lens. Humans came to Europe via the Balkans or the Levant. But there was always something missing. Genetic studies showed unexpected diversity in European populations that didn't quite match the predicted patterns from these two routes. And there were gaps, mysterious periods where we couldn't find archaeological evidence of human presence in the expected locations. Some scientists suspected there might be other routes, but they had no proof. The Mediterranean is a complex region with constantly shifting coastlines, tectonic activity, and rising sea levels that have hidden ancient landscapes beneath the waves. Until now, no one knew about the third route. No one suspected that an entire land bridge, connecting Asia to Europe through the Aegean Sea, once existed and served as a major migration corridor for thousands of years. In October 2025, everything changed. A team of Turkish archaeologists from Hacettepe University, Ankara University, and several other institutions published their findings in the Journal of Island and Coastal Archaeology. What they discovered off the coast of Ayvalık, Turkey, would rewrite human prehistory. Ayvalık is a quiet coastal district in northwestern Turkey, famous today for its olive groves, charming islands, and seaside cafes. But tens of thousands of years ago, this region looked completely different. The research team, led by Dr. Göknur Karahan, used a combination of cutting-edge technologies, drones, satellite imaging, underwater surveys, and ground-based archaeological excavations. Their goal was to map the ancient landscape that existed during the Pleistocene epoch, the last ice age. What they found was extraordinary. During the Ice Age, sea levels were more than 100 meters lower than they are today. To put that in perspective, that's equivalent to a 30-story building. Imagine draining the Aegean Sea by 100 meters. Entire islands would become mountain peaks. Channels would become valleys. And most importantly, what is now open water would become dry land. When the team reconstructed the ancient geography of Ayvalık, they discovered that the current islands and peninsulas weren't islands at all during the Ice Age. They were part of a massive, continuous landmass, a natural bridge connecting western Anatolia in Turkey to southeastern Europe. Dr. Karahan described the discovery in a press statement. Our archaeological discovery has unveiled that this now idyllic region once potentially offered a vital land bridge for human movement during the Pleistocene era. When sea levels dropped, and the now submerged landscape was briefly exposed. But the real evidence came from what they found on the ground. Across 10 different archaeological sites spanning 200 square kilometers, the team uncovered 138 Paleolithic stone tools. These weren't just random rocks. These were sophisticated stone implements crafted by human hands tens of thousands of years ago. The tools included Levallois-style flakes, a specific stoneworking technique that requires advanced planning and skill. The most significant discovery? They found Mousterian tradition tools, large cutting implements typically associated with the Middle Pleistocene period, dating from around 774,000 to 129,000 years ago. These tools have historically been linked to both early Homo sapiens and Neanderthals. Dr. Karahan emphasized the importance. These large cutting tools are among the most iconic artifacts of the Paleolithic and are instantly recognizable even today, so they are a very important find. The presence of these objects in Ayvalık is particularly significant, as they provide direct evidence that the region was part of wider technological traditions shared across Africa, Asia, and Europe. This means that Ayvalık wasn't just a random stopover. It was a crucial corridor, a highway of human migration that connected continents and cultures for tens of thousands of years. Section 4. The Ice Age World, 11 to 16. To understand why this land bridge existed, we need to step back in time and understand what the world looked like during the last Ice Age. The Pleistocene epoch lasted from approximately 2.6 million years ago until 11,700 years ago. During this period, Earth experienced repeated glacial cycles. Massive ice sheets would advance and retreat across the northern hemisphere in cycles lasting tens of thousands of years. During glacial maximum periods, enormous amounts of water became locked up in ice sheets and glaciers. The polar ice caps expanded dramatically. Ice sheets covered Canada, Scandinavia, and much of northern Europe. Some ice sheets were over 3 kilometers thick. When that much water is frozen and sitting on land as ice, it has to come from somewhere, and that somewhere is the ocean. As a result, global sea levels dropped dramatically. Scientists estimate that during the peak of the last glacial maximum, around 20,000 years ago, sea levels were 120 to 130 meters lower than they are today. This lower sea level transformed the world's geography. Coastlines extended far beyond their current boundaries. Shallow seas became dry land. And most importantly for our story, land bridges emerged. The most famous example is the Bering Land Bridge, also called Beringia, which connected Alaska to Siberia. This land bridge allowed humans and animals to cross from Asia into North America, eventually populating the entire Western Hemisphere. Another example is Doggerland, a now submerged landmass that connected Britain to continental Europe across what is now the North Sea. Doggerland was a rich, fertile landscape with rivers, forests, and abundant wildlife, until rising sea levels submerged it around 8,000 years ago. The Ayvalık land bridge formed in exactly the same way. As sea levels dropped, the shallow waters of the Aegean Sea receded. The islands and peninsulas that dot the Turkish coast today became interior highlands within a vast terrestrial landscape. Professor Kadriye Özçelik from Ankara University, a co-author of the study, explained, "In all these periods, the present-day islands and peninsulas of Ayvalık would have formed interior zones within an expansive terrestrial environment." So what did this land bridge actually look like? Based on the archaeological evidence and paleogeographic reconstructions, scientists have painted a detailed picture. The landscape was a mix of coastal plains, river valleys, freshwater lagoons, and elevated plateaus. Springs bubbled up from underground aquifers, providing reliable water sources. Flint deposits, essential for making stone tools, were abundant in the rocky outcrops. The climate would have been cooler than today, but not Arctic. Think of a temperate Mediterranean climate with cold winters and mild, wet summers. The vegetation would have included grasslands, scattered woodlands, and shrubby plants, perfect habitat for large herbivores like deer, wild cattle, and horses. For early humans, this landscape was ideal. It offered everything they needed: fresh water, stone for tools, game animals for hunting, plants for gathering, and most importantly, a safe corridor between continents. The land bridge was wide enough that migrating groups wouldn't face dangerous water crossings. They could simply walk from Asia into Europe, following herds of animals and seasonal food sources. This wasn't a brief window of opportunity. The land bridge existed intermittently throughout the Pleistocene, appearing and disappearing as sea levels rose and fell with each glacial cycle. This means multiple waves of human migration could have used this route over tens of thousands of years. Section 5. Who walked across? 1600 to 2100. Now comes the most fascinating question. Who actually used this land bridge? The answer is more complex and more incredible than you might expect. The stone tools discovered in Ayvalık date from various periods throughout the Pleistocene. This means the land bridge wasn't used by just one group of humans. Multiple hominin species crossed this corridor over hundreds of thousands of years. The earliest tools found follow the Mysterian tradition, which archaeologists typically associate with Neanderthals. Neanderthals, or Homo neanderthalensis, were a distinct human species that evolved in Europe and Western Asia approximately 400,000 years ago. They were powerfully built, adapted to cold climates, and used sophisticated stone tool technologies. For decades, scientists debated how Neanderthals first reached Europe from Africa. The Ayvalık discovery suggests that at least some Neanderthal populations may have migrated through this Aegean land bridge route, possibly during earlier glacial periods hundreds of thousands of years ago. But Neanderthals weren't the only ones. The Levallois-style flake tools found at Ayvalık are also associated with early Homo sapiens, our direct ancestors. These tools represent a more advanced stoneworking technique that emerged in Africa around 300,000 years ago and spread with human migrations. This means that both Neanderthals and Homo sapiens used the same migration corridor, possibly at different times, possibly even overlapping. When Homo sapiens entered Europe around 45,000 to 50,000 years ago, they encountered Neanderthal populations that had been living there for hundreds of thousands of years. We know from genetic evidence that these two species didn't just coexist, they interbred. Modern humans of non-African descent carry between 1 and 4% Neanderthal DNA in their genomes. This interbreeding likely happened in regions where their populations overlapped, possibly including areas around the Ayvalık land bridge. Imagine the scene. Small groups of Homo sapiens, perhaps 20 to 30 individuals, moving slowly across the landscape. They're following herds of deer or wild horses. They stop at freshwater springs to refill water containers made from animal bladders. They camp on elevated ground where they can see approaching predators. At one of these campsites, they encounter another group, Neanderthals. The two groups are cautious at first. They look different. Neanderthals are shorter but more muscular, with prominent brow ridges and larger noses adapted to cold air. Homo sapiens are taller and more slender, with higher foreheads and smaller faces. But they share something crucial. Both groups are intelligent, social, and tool-using. They can communicate, at least to some degree. Perhaps they trade, stone tools for food or information about water sources and game animal movements. And sometimes, despite their differences, individuals from the two groups formed relationships. Children were born with mixed ancestry, carrying genes from both species. These hybrid individuals survived, had their own children, and passed on that Neanderthal genetic legacy to all of us today. The Ayvalık land bridge may have been one of the key locations where these momentous encounters happened, where two branches of the human family tree intersected, forever altering the course of human evolution. But there's another dimension to this story. The tools found at Ayvalık show connections to technological traditions from three continents: Africa, Asia, and Europe. Dr. Karahan specifically noted that these artifacts provide direct evidence that the region was part of wider technological traditions shared across Africa, Asia, and Europe. This suggests that the land bridge wasn't just a one-way migration route. It was a corridor for cultural exchange, knowledge transfer, and technological innovation flowing in multiple directions. Ideas about how to make better tools, how to hunt more effectively, how to process plant foods, all of this information could have traveled along this route, spreading between populations across vast distances. Section 6. Challenging Old Theories, 2100 to 2500. This discovery fundamentally challenges the traditional two-route migration theory that has dominated archaeology for over a century. But how exactly does it change our understanding? First, it explains genetic anomalies. Population genetic studies of modern Europeans have long shown unexpected diversity that didn't quite fit the predicted patterns from Balkan and Levantine migrations alone. Some European populations carry genetic markers that suggest their ancestors came from different source populations in Asia. The Ayvalık land bridge provides a third entry point that could account for these genetic patterns. If multiple waves of humans entered Europe through three different routes over tens of thousands of years, the resulting genetic diversity would be much more complex than previously predicted. Second, it fills archaeological gaps. There have always been mysterious periods in European prehistory where we find human artifacts in certain locations but can't explain how those humans got there. The traditional routes through the Balkans or Levant didn't always align with the archaeological timeline. The Aegean land bridge route provides an alternative explanation. Humans who entered Europe through Ayvalık would have dispersed into different regions of southern and eastern Europe, creating archaeological sites that don't fit the expected patterns from northern routes. Third, it changes our understanding of Neanderthal Homo sapiens interactions. If both species used the same Aegean corridor, possibly at overlapping times, this region becomes a crucial zone of contact and interbreeding. Previous theories focused on interactions in the Levant or Central Europe, but the Ayvalık area may have been equally or more important. Fourth, it highlights the role of climate and sea level changes in human evolution. The land bridge didn't exist continuously. It appeared and disappeared multiple times as sea levels fluctuated with glacial cycles. This means migration opportunities were episodic and climate-dependent. Humans had to time their migrations with periods when the land bridge was exposed. Miss the window and you'd face dangerous water crossings. This adds a layer of environmental determinism to human migration stories. Our ancestors' movements were constrained and enabled by forces beyond their control. Professor Özçelik emphasized this point. These paleogeographic reconstructions highlight the importance of the region for understanding hominin dispersal across the northeastern Aegean during the Pleistocene. The discovery also raises important questions about why this route wasn't discovered sooner. The answer lies in the unique challenges of Aegean archaeology. This region has experienced dramatic geological changes over the past 11,000 years. Rising sea levels submerged ancient coastlines. Tectonic activity shifted land masses. sediment deposition buried or destroyed archaeological sites. As the researchers noted, the Aegean's shifting geomorphology can significantly impact the preservation of Pleistocene remains. Many archaeological sites that once existed on the ancient land bridge are now 100 meters underwater, buried under marine sediments and inaccessible without advanced underwater archaeology techniques. This is why Ayvalık is so remarkable. The region preserves traces of the ancient land bridge in a way that other areas don't. The stone tools survived because they were made of durable flint that doesn't decay. They were buried in sediments that protected them from erosion, and they were located in areas that modern researchers could actually access and survey. Dr. Karahan expressed the team's excitement. "We are very excited and enthusiastic about this discovery. These findings mark Ayvalık as a potentially new frontier in the history of human evolution, firmly placing it on the map of human prehistory, opening up a new possibility as to how early humans might have entered Europe." The Ayvalık discovery raises an obvious question. If this land bridge was hidden for over 11,000 years, what other lost migration corridors might be submerged beneath the world's oceans? Scientists are now looking at other regions with renewed interest. The Mediterranean and Aegean seas are particularly promising. During glacial maximum periods, sea levels dropped so dramatically that entire sections of these seas became dry land or shallow lagoons. Between Greece and Turkey, multiple islands could have formed stepping stones or continuous land bridges. The islands of Lesbos, Chios, Samos, and Rhodes, currently separated by water, would have been connected to the Turkish mainland during low sea level periods. Similarly, the strait between Sicily and Tunisia was much narrower during the Ice Age, possibly allowing humans to cross from North Africa into Europe through Sicily and then to mainland Italy. Some researchers speculate about land connections between Crete and the Greek mainland, though the waters there are much deeper and would require even more dramatic sea level drops. Beyond the Mediterranean, other candidate regions include Southeast Asia. During the Ice Age, sea levels exposed a massive landmass called Sundaland, connecting what is now Indonesia, Malaysia, and Thailand. This allowed humans and animals to disperse across the region without water crossings. Much of this ancient landscape is now submerged beneath the South China Sea and Java Sea. In the Arabian Gulf, lower sea levels exposed a large plain that may have supported human populations and served as a migration corridor between Africa and Asia. Archaeological evidence from this region is scarce because most sites are now underwater. The discovery of these submerged landscapes requires advanced technology. Underwater archaeology has traditionally been expensive and technically challenging, but new tools are making it more accessible. Autonomous underwater vehicles, multi-beam sonar mapping, and satellite remote sensing can now identify submerged archaeological sites without expensive diving operations. Dr. Karahan and her team emphasized that their research opens up exciting possibilities for future studies. Our research opens up exciting possibilities for future research, and we hope it will become a body of work that will change the approach to Pleistocene archaeology for decades to come. The Ayvalık project used drones and satellite imaging to identify ancient coastal features that are still visible in the modern landscape. By combining these aerial surveys with underwater investigations and geological coring, researchers can reconstruct ancient environments even when most of the evidence is submerged. The implications extend beyond human migration. Understanding how sea level changes created and destroyed land bridges helps us comprehend how animals, plants, and even diseases spread across continents. Many modern biogeographic patterns, why certain species are found in some regions but not others, can be explained by Ice Age land bridges that no longer exist. Climate scientists are also interested in this research. As we face modern climate change and rising sea levels, understanding how past sea level changes affected human populations provides valuable insights. Coastal communities have always been vulnerable to sea level fluctuations. The Ayvalık land bridge existed for thousands of years, then vanished relatively rapidly as glaciers melted at the end of the Ice Age. Entire landscapes that supported human populations for millennia were submerged within a few thousand years. Communities that had lived on the land bridge for generations would have been forced to migrate as their homeland gradually disappeared beneath rising waters. This is a cautionary tale for our own era of climate change. So what does this discovery really mean? For over a century, we've told a simple story about how humans left Africa and populated Europe. Two routes, the Balkans and the Levant. Clean, straightforward, easy to teach. But the truth is far more complex, far more fascinating. Humans didn't follow two neat highways. They used multiple routes, multiple strategies, over hundreds of thousands of years. They adapted to changing climates, changing sea levels, and changing landscapes. They were opportunistic, creative, and persistent. The Ayvalık land bridge represents a completely new chapter in the human migration story. It shows that the Aegean region, now known for tourism and olive oil, was once a crucial corridor connecting continents and cultures. Both Neanderthals and Homo sapiens walked across this landscape, hunted on these plains, camped by these springs, and eventually encountered each other. This discovery also reminds us how much of human history remains hidden. Beneath every coastline, every shallow sea, every continental shelf, there are ancient landscapes with stories to tell. The Ayvalık land bridge was there all along, just waiting for someone to look in the right place with the right tools. As sea levels continue to change and archaeological techniques improve, we'll undoubtedly discover more lost worlds. Each discovery will add new complexity, new nuance, and new wonder to the human story. The next time you look at a map of the Mediterranean, imagine what it looked like 20,000 years ago. Imagine the islands connected, the shallow seas as dry land, and small groups of humans walking across that landscape carrying everything they owned, searching for new horizons. They had no idea they were making history. They were just surviving, exploring, and trying to find better places to live. But their journeys shaped all of human civilization. Every European alive today is descended from someone who made that journey, possibly someone who walked across the Ayvalık land bridge that now lies silent and hidden beneath the waves. The past is not dead, it's not even past, it's just underwater, waiting to be rediscovered. What other lost chapters of human history are still hidden beneath the oceans? What other land bridges, other migration routes, other encounters between different human species remain undiscovered? The Ayvalık land bridge is just the beginning. If you found this story fascinating, subscribe to Lost Worlds Decoded for more deep dives into ancient mysteries and archaeological breakthroughs. Leave a comment below. Do you think there are other hidden land bridges waiting to be discovered? And check out our other videos exploring the lost civilizations and forgotten worlds of human history. Until next time, keep exploring the past, because every discovery changes what we thought we knew.